Welcome back to the Woodbridge Geometry Virtual Tutor for another episode. We're going to be working in the right triangles and trig unit. This is going to be a continuation of Pythagorean theorem. So we're going to be able to use Pythagorean theorem to determine if a triangle is right, obtuse, or acute. So the Pythagorean theorem is used when finding the side of right triangles. However, because it works for right triangles, it can also help us determine if a triangle is right, obtuse, or acute. So let's think about those vocabulary words. We know right means there's a 90-degree angle. Obtuse means greater than 90. And acute means less than 90 degrees. So we have a hint there. So you must first determine which side is C. It will always be the largest side, because if the triangle is a right triangle, it would be across from the 90-degree angle, which would make it the largest side. So what that's stating is biggest angle, biggest side, smallest angle, smallest side. That's going back to your triangle properties. So here's how we know what type of triangle we have. If a squared plus b squared equals c squared, then the triangle is right. If a squared plus b squared is greater than c squared, then the triangle is acute. So that's looking at the sum of your two legs. So you're saying those two sides squared, add them together, that's larger than your hypotenuse. So that means your value has to be small. It's acute. It's less than 90. If a squared plus b squared is less than c squared, that means c is greater than both sides squared and combined. So that means this is an obtuse triangle. So for all of these, you're looking at your c value. You're comparing the two sides to the c value. If a squared plus b squared equals c squared, we know it's a right triangle. If a squared plus b squared is greater than c squared, it's an acute triangle because c is small. If a squared plus b squared is less than c squared, it's obtuse because c is large. So there's kind of three steps here to solving these. Step one is check to make sure the lengths can form a triangle. In order to form a triangle, we need to check to make sure it passes the triangle inequality theorem. Your triangle inequality theorem states the sum of two sides must be greater than the third. If it passes your triangle inequality theorem, then you need to go to step 2. If it does not pass, you are done and the triangle cannot be formed. So if it passes, we need to then go to step 2, identify which is the largest side of the lengths given, and then we use Pythagorean theorem to determine which type of triangle it is. So we know there could be three options. There could be a right, acute, or obtuse. So there will be three outcomes that we potentially could have. So let's go ahead and give these a try. So our examples, if possible, determine if the given side measures of each triangle is acute, right, or obtuse. Number 1, they gave us three lengths. We have 15, 22, and 25. So we know step 1 is check to make sure this is a triangle. So we need to use our triangle inequality theorem that states the sum of two sides must be greater than the third. So if we take the first two, 15 plus 22, that gives us 37. 37 is greater than 25, so that's good. We need to check our other sides. So 15 plus a 25 gives us a 40, which is greater than our third side of 22. So far, so good. We have one last option to check out, we have 22 plus 25 gives us a 47, which is greater than 15. So this one does form a triangle. So it's going to form a triangle. That means we can move to step 2. Step 2 is identify which is your largest side. So 15, 22, 25. Which one is the largest? We know that is 25. That is going to be your C in Pythagorean theorem. Pythagorean theorem, a squared plus b squared. Leave a blank because we don't know if it's equal to, greater than, or less than. Let's substitute in. We know 15 and 22 are our a and b values. So we're going to have a 15 squared plus a 22 squared. Leave a blank. We don't know the sign. And 25 squared. So when we square 15, we get 225 plus 22 squared, which becomes 484. And 25 squared is a 625. On the left, we can combine our like terms, so we're going to add up those two. We have 225 plus a 484, giving us a 709 in comparison to 625. So right there, we know those two numbers are not equal, so it can't be a right. We know 709 is larger than 625. So we know the sum of the two bases a plus b squared is greater than c squared. So when that happens, that means c is small. So this is an acute triangle. Number 2, we have 3, 4, and 7 for our measures. First thing we need to do is identify if this is a triangle. So you're going back to your triangle inequality theorem. The sum of two sides must be greater than the third. Let's check it out. We have a 3 plus a 4. 3 plus a 4 is a 7, and our third side is a 7. So this one is not greater than our third side. So this cannot be a triangle. And that would be your final answer. It is not a triangle. Go ahead and hit pause for me and try number 3. So you're going to go through your 3 steps and determine your outcome. So hit pause and try 3. All right, so first thing you should have done when you hit pause was to first see if this forms a triangle. Sum of two sides must be greater than the third. So we should have took 6 plus a 9, we get 15. Your third side was 12, so we know 15 is greater than 12. That's good. Check another two sides. We have 6 plus a 12 gives us 18. Your third side there was 9, so 18 is larger than 9. That's what you want to happen. And you have one more side to check out. We have 9 plus a 12 gives us 21, which is greater than 6. So we know those three sides will form a triangle. So we can move on to step 2. Step 2, we need to identify which is our C value. We know C needs to be the largest value. So 6, 9, and 12. Of those three, we know 12 is the largest, so that is going to be your C value. So going to Pythagorean theorem. A squared plus b squared. Leave a blank because we don't know that symbol. And then we have c squared. We know c in this problem is 12. And our a and our b are the other two side lengths. So we have 6 squared plus a 9 squared, and we're still going to leave that blank in between to 12 squared. And then we go ahead and square everything out. So 6 squared becomes a 36, plus a 9 squared, 81. Leave a blank, and 12 squared we know becomes 144. We combine like terms, so we add the 36 and our 81. We get 117 in comparison to 144. We know those two values are not equal, so it cannot be a right triangle. We know 144 is greater than 117. 144 is your hypotenuse. That's saying your C value is larger than the other two values. So that makes it an obtuse triangle. Example 4. We have the square root of 38, the square root of 25, and the square root of 13. So let's not let the square roots scare us away. Let's use those. So what I want you to do is go ahead and take out your calculator so we can get an estimate or an approximate value of what these come out to be. All right, so first thing we need to do is figure out, can this form a triangle? So in your calculator, we want to look at all the options. We have the square root of 38 plus the square root of 25, which we know is just a 5. So if we take our calculator, we can put in the square root of 38, close your parentheses, and then we can add a 5. So that comes out to be approximately 11.16 in comparison to our third side, which is the square root of 13, which is 3.6 approximately. So we know that value is greater than the square root of 13. That's good. Next, we have our 5 plus the square root of 13. Go back to your calculator, type in 5 plus the square root of 13. We get about 8.6. We need to compare that to the square root of 38, which is 6.16. So we know 5 plus the square root of 13 is greater than the square root of 38. And we have one more side to check out. We have the square root of 38 plus the square root of 13. That needs to be greater than 5 for this to be a triangle. So go ahead and put in the square root of 38 plus the square root of 13. And that comes out to be approximately 9.77. So that is greater than our third side of 5. So this is going to form a triangle. So we can go on to step 2. Step 2 wants us to identify what your largest side is. So we already knew the square root of 25 was 5. So if we put in the square root of 38 in our calculator, that's approximately 6.2. And if we look at the square root of 13, that comes out to be approximately 3.6. So looking at those, we know 6.2 is the largest side. That has to be your C value. Going back to Pythagorean theorem, a squared plus b squared, leave a blank because we don't know that sign, c squared. So we know the square root of 25 squared plus the square root of 13 squared in comparison to the square root of 38 squared. So we need to talk about what happens when you have a square root and it's being squared. Anytime you have a square root that's getting squared, it just cancels right out. So what that means is 25 squared just becomes 25. If you don't remember that, you can go to your calculator and type it in. So we have the square root of 25. That's all being squared. That just gives you a 25. You can do the same thing with the square root of 13 and square that value. Square root and square cancel, you're left with what's underneath your radical. That's a 13. And we also have the square root of 38 here that's being squared. Again, square root and square cancels, we're left with a 38. So we just said the square root of 13 squared was 13, and the square root of 38 squared was a 38. We can combine our terms. 25 plus 13 gives us a 38. So if we're comparing both sides, left to right, we know 38 and 38 are equal. So if they're equal, we know this is a right triangle. So you guys just saw examples on when you would not have a triangle, when it's right, when it's acute, and when it's obtuse. So first thing you always need to do is determine, can it be a triangle? Step 2, if it can be, we are going to identify what the largest side is and then apply Pythagorean theorem. Leave a blank for your sign until you figure that out at the bottom when you can compare your numbers. Have a great day, guys.